Welcome to Cheenta Statistics and Data Science. Today we are going to solve this problem from IIT JAM MS 2020, problem number 30. The problem says that let x1 through xn be a random sample from a distribution with PDF. This f theta of x is equals to theta into 1 minus x to the theta minus 1 for x in 0 to 1, 0 otherwise, where theta is greater than 0. This thing. To test h naught theta equals to 1 against h1 theta greater than 1, the uniformly most powerful test of size alpha would reject h naught if, so there are four options. So basically we have to find the test rule for rejecting h naught, the UMP, the uniformly most powerful test. Now here the null hypothesis is simple, but the alternative hypothesis is composite, right? So what we're gonna do is, see, basically you can write this same thing, this thing as h naught says theta equals to 1 against h1 theta equals to theta 1, where theta 1 is greater than 1, right? Basically we need to, this is just the same thing, theta greater than 1. Here we're just choosing theta to be a particular theta 1 where theta 1 is greater than 1. Now by the Neyman-Pearson lemma, the most powerful size alpha test is of the form: if under each one of random sample divided by if under h naught of random sample the x curl is greater than k, where k is a real number such that the size is alpha, right? So here it's under each one, this entire thing here, just the same thing, just product under the hypothesis that h1 is true, this product of the entire joint PDF, right? The product of the entire individual PDFs, because here it is IID, so the joint PDF is nothing but the product of the individual marginal PDF. So this is product of theta into 1 minus xi to the theta minus 1 divided by 1, because obviously this under theta equals to 1, this is nothing but just 1, right? If theta of x is nothing but 1, so joint PDF is 1. Therefore this is nothing but theta to the n into product of xi whole to the theta minus 1 greater than k, right? Now this is nothing but product of 1 minus xi whole to the theta minus 1 greater than k by theta to the n, right? Again taking log and doing all this stuff just so that taking and just to make a function of the xi's in the LHS and a constant in the RHS. So ultimately this thing is nothing but summation ironing from 1 to n natural log of 1 minus xi is greater than c, right? Just dropping this theta with theta minus 1 here, and ultimately we get this summation log of 1 minus xi greater than c. So the MP critical region is of the form reject h naught if and only if summation natural log of 1 minus xi greater than c. Now we have to find the c, right? See, alpha is the size of the test. That means alpha is equals to probability under h naught reject h naught. Now rejecting h naught is this. The rule is this: summation log of 1 minus xi greater than c. Now under h naught, the function is this, right? Basically uniform. So under h naught, x1 through xn follows IID uniform 0 1 standard uniform, right? Now we know that if x follows uniform 0 1, then 1 minus x also follows uniform 0 1, right? So therefore 1 minus xi also follows IID uniform 0 1, right? For I 1 through n, right? Therefore, minus 2 log of 1 minus xi follows chi square 2. We know this transformation, the sampling distribution, right? This is minus 2 natural log of 1 minus xi follows chi square 2. Therefore, this taking summation, that means adding up all those things for each of the random variables x1, x2 up to xn, this entire thing minus 2 summation log of 1 minus xi follows chi square 2n. Remember, because there are n such things and each of them follows chi square 2. So this is chi square 2n. The degrees of freedom add up in chi square distribution since they are independent after all. So this entire thing follows chi square 2n distribution, right? Now, so ultimately coming back to this problem, this thing, alpha is equals to probability under h naught, this thing greater than c. Now just multiplying minus 2 both sides, this minus 2 of summation log of 1 minus x is less than minus 2 c, minus 2 into c, right? This thing, this entire thing is actually chi square 2n. So chi square 2n, so this is nothing but probability under h naught, chi square 2n is less than minus 2c. This thing is alpha, right? That means probability chi square 2n greater than minus 2c is actually 1 minus alpha, right? Just reversing the inequality is, therefore it is minus 1 by 1 minus alpha, right? This thing here it was alpha, this thing being less than minus 2c. Now this thing be greater than minus 2c is actually 1 minus alpha. This means this minus 2c is actually nothing but the upper cutoff point, right? So minus 2c is actually chi square 2n comma 1 minus alpha, because beyond this point the probability that the chi square 2n is greater than this particular point is 1 minus alpha. Therefore this point is minus 2c must be chi square 2n comma 1 minus alpha, right? This thing, therefore c is actually nothing but minus half into chi square 2n comma 1 minus alpha, which does not depend on theta, right? This thing does not depend on theta. That means the MP test we just found is actually not just the MP test, it is the UMP test. So MP size alpha test is actually UMP size alpha test, which rejects H naught if and only if this entire thing is greater than this entire thing. Remember the rule was summation log of 1 minus x greater than c. C here is minus half into chi square 2n comma 1 minus alpha. Therefore, just reversing this sign here, this multiplying minus on both sides, we get this here is going to be a minus. Yeah, yeah. So 2 here is going to be here. Just square it. Just 2. This particular 2 is going to the LHS, and there, since it's a log, so it's natural, so it's minus summation I running from 1 to n natural log of 1 minus xi whole square. Here the 2 is actually, this 2 is actually here, because just it's moving here to the LHS, and then being the log thing, the log, it just takes it to the power of 1 minus xi. So ultimately it's minus summation I running from 1 to n natural log of 1 minus xi whole square less than chi square 2 n comma 1 minus alpha. So this is the rule. So this is the UMP test of size alpha, right? So yeah. So yeah, there you have it. It is a very straightforward problem. It was a UMP test, but ultimately it was nothing but try just same as finding the most powerful test, right? Because the the rejection region is actually independent of the parameter theta, so it doesn't matter. So yeah, it was, and obviously the sampling distributions and all, you have to know that to solve this problem. But other than that, it is very easy. So yeah, there you have it, the solution to this problem. So do like, share, and subscribe to the channel for more exciting problems. See you till next time.